सत्यम कैसे हो?
बढ़िया हूँ मैम। आप कैसे हैं?
ऑल गुड ऑल गुड। आप कल जूम नहीं इनवाइट मिला था ना आपको, वहां पे शो नहीं हो रहा था।
हाँ मैम, बट आई थॉट कि यूट्यूब पे लाइव स्ट्रीम हो रहा है तो वहां देखते हैं। और
हम्म।
इंस्टॉल भी नहीं था जूम मैम।
ओके। आज भी लाइव स्ट्रीम हो ही रहा है तो।
यस
बट आज ये है कि यू विल बी एबल टू टॉक हियर।
मैम। यस मैम।
बाकी लाइव बाकी भी देख सकेंगे, बट यू पार्टिसिपेंट्स जिनको जूम चला गया है, दे विल बी एबल टू टॉक ऑल्सो। चलो 9 o'clock हो गए हैं तो
यस मैम।
वी शैल स्टार्ट। सो फर्स्ट थिंग, स्क्रीन शेयर दिख रहा है मेरा? मैंने अभी जस्ट स्क्रीन
हाँ
स्टार्ट
यस
किया
मैम,
है।
दिख रहा है।
ओके। तो नाउ एनी क्वेश्चन फ्रॉम डे वन? सब समझ में आ गया था?
हाँ यस मैम।
ठीक है। सो लेट्स नाउ स्टार्ट। वी टुडे इज डे टू। ओके। So we have to start a discussion regarding IP addressing. Hi Shiva, how are you? Am I audible?
Hi, ma'am.
Okay, okay, great, great. All right. So today's topic is IP addressing. So we have to start with IPs and all. Yesterday we set one goal. Why we need IPs and all? We need IP because we want to use internet, and in order to use internet, you must have IP address. Without IP, you will not be able to communicate with anything. So what is the theory behind IP addressing and all? So number one, IP addressing, subnetting, nutting, all those topics, they are very connected with each other. So they all are based upon RFC number 1918 again. Okay, so that means if you will be searching on the Google what is RFC number 1918, so there's so many things that you will find. So number one, we have IP addresses. Every IP address, it is part of certain class. So we have IP classes. How many classes we do have? Class A, then we do have class B, and we have class C, then we have class D, class E. Okay. Class A, that means if any IP is starting the number, just a starting number of IP, we call it first octet. Okay, so it is called first. You have to guess the IP by seeing the first octet. So that means there is a second octet also, third also, fourth also. So when you talk about IPv4, there are how many octets? Total 4 octets. One octet, because every IP will look like this. For example, 10.11.12 dot, let's say 1 or 2, whatever. This is IPv4 addressing scheme. So this is called your first octet. 10 is first octet, 11 is second octet, 12 is third octet, and 1 is the last octet, fourth octet. Now what is this octet thing? It is saying every IP address octet or every portion. So that you see it is IPv4. This 4 stands for these 4 options. Okay, because you have 4 numbers dotted and all. So now every number, right now we are seeing in decimal, every number internally is implemented in binary. So that means you have a binary. Your system will understand everything into binary. How your system will understand? It will first convert everything into 8-bit representation. Satyam, you remember 8-bit representation?
हाँ यस मैम, लिटिल बिट।
Okay. So 8-bit representation means, for example, let's say if I have to write 10, okay? So in number system, then normally if I'm saying I'm going to send you 100, not 100, let's say I'm going to send you 671 Indian rupees in your bank account, okay? And let's say Satyam is saying, okay, I'm going to transfer 671 rupees or any amount. But at end of the day, he got 167. Satyam, are you happy after having 167?
नो मैम।
So because it is not just digits who are matter, Their place values are also very important in number system. In decimal number system, we know this is not, this 167 is not equal to 671, because 671 is 600 plus 70 plus 1, and you know the other thing. So, but now we will break it down further. It is 6 multiplied by 10 raised to power 2. Similarly, you have 70, it is 7 multiplied by 10, and then plus 1 multiplied by 1. So now there are some chunks you have to understand. One, the first thing that you are multiplying with 10, okay? This is called digits that belongs to that number system. This is decimal number system. What are the digits in decimal number system? 0, 1, 2, 3, then you have 4, 5, 6, 7, 8, 9. Can I write 10? What do you think? 10 is also a symbol or not? No. Okay, because it is the combination of this symbol and that symbol. Every number system, there are different symbols who are participating into it. So their combinations can give you different weightage and value. So we do have total 10 symbols in decimal number system. Deci means 10 in Greek language. So that is the reason it is called base 10. So can anyone tell me what will be the base for binary? If decimal number system is base 10, what is the base for binary?
2, ma'am.
Yes, it is 2. Why it is 2? Because the symbols that we use are only 2. So now what we understood, what is the significance of these symbols? These symbols that mean whatever the number right now you are having 671, 167 and all. So whatever the number you will have in binary like 0, 1, that will be the repetition of 1 and 0 combination, let it be any number. But now they will be the digits that will come here. So that means either here you will be finding 0. So let's say if it is a 0, then 10 was base here, it could be 2 because it is in binary, and then you will always have some place value. What do we mean by place value? We know very well from our schools only. This is called ones place, this is called tens place, this is called hundreds place, and so on. So exact thing. So ones place means your base number system raised to power 0. Anything raised to power 0 is 1 only. Okay, so that is first place, ones place. And then 10 raised to power 1 will give you 10. That is called tens place. 10 raised to power 2 will give you hundreds place. Okay, so now similar for binary, you will also be doing the same thing. Why I'm writing these things? Because you should not be thinking binary is the only system where you are following this logic. It is actually number system, and you are following the same thing from childhood only. So here it will be 2 raised to power 0 in case of binary, 2 raised to power 1, and 2 raised to power 2, so on. So if it is 3-digit number, okay, so we can also call this is a 3-bit representation, but it's not the right answer right now, but I'm just giving you some idea. So this is a 3-digit number. Same thing in binary, we don't say this is 2-digit or whatever, we can say number of bits. So if it is 0 only or 1 only written, it is called 1-bit representation. If I am saying 00 or any other combination of 0, 1 or whatever you can imagine of, so this is called 2-bit representation. Similarly, you can have 3-bit representation. Any combination can come. So in IP address, we do have how many octets? We do have 4 octet. Octet 1 dot, octet number 2 dot, octet number 3 dot, octet number 4. So if I have to ask you, here the number is 10, here the number is 11, and here the number is 12, and here the number is 1. So you have to, your system will be converting every octet into, octet means 8-bit representation. So that means now you can write 10 like this. It will be 2 raised to power 7, then 2 raised to power 6, then 5, 4, 3, 2, 1. Like that it will be going on. If you will calculate, their values will be 128, then 64, then 32, then 16, then 8, 4, 2 and 1. So usually I started from left to right direction, but normally we start from left, opposite way, right to left. So this is called 2 raised to power 0. This is 2 raised to power 1. This is 2 raised to power 2. This is 2 raised to power 3, 4, 5, 6, and 7. So total now how many bits are there? 1, 2, 3, 4, 5, 6, 7, and 8. Okay, so that is the reason it is called 8-bit representation. So now this same logic will be applied on all the 3 other octets also. So 10, if I have to ask you how you will represent 10 in binary now, what will be the binary of 10? How you will understand binary? So binary is very simple. Either one place value is present or it is not, just like this. It is not giving up with any weightage. Either it is there or not. That means either 100 is there or it is not there. Simple. That means you will be adding 100 into the final value or you will not be adding. So now I have to represent 10. I have to give the combination from this in such a way that the sum will be equal to, because at end of the day you are calculating sum only, you see here. So that means you have to multiply each place value. This is called place value, 128, 64 and blah blah. So you have to multiply each place value with the symbols of the base, that means 0 or 1, in such a way that after applying this logic it should be equal to the desired number in decimal, that whatever you are now interested in. So that means number 10 will be, do I need 128 to multiply with 1 or 0? What will be the value here? Shall I multiply this value? So you can imagine this second line is going to be the operation of multiplication. 128, shall I apply 1 or 0 here? Do I need to multiply 128 in the final sum or not? Yes? Any suggestions? No idea? Am I audible? Yes, are you guys listening me?
Yes, ma'am.
Okay, I thought maybe I have network issue also today. So in writing 10, we have to have 128 multiplied with 0 only. Here also it should be 0. Here it is also should be 0. This is also 0. This is 1 and this is 0. This is 1. This is 0. Okay. So every IP address octet will be represented like this. So we do have total 4 octet. That means 11 will also be represented like this in binary. 12 will also, you will calculate the code. 1 you always again calculate. So now total, if you will see, 8-bit are here, 8-bit are here, 8-bit are here, and 8-bit are here. So total how many bits we do have in IP address now? 32. 32-bit in binary, we do have IP address. Every IP address will look like this. So now we are saying if the first octet is starting with as per these details. Okay, so now I'm going to give that class ABC value. So we have a range. Class A is from 0 to 127. Now here there is a condition, 0 and 127. Both are not used for configuration of our IP. That means you cannot assign any user as IP that will be starting from 0 and 127, because they have different meaning in networking that you will understand later on. So the valid inputs, valid IPs that they can be in class A that you can give to somebody, it will be any number that can start from 1, 2, 3, 4, 5 up to 126. So that means if the first octet you are able to see any IP is starting with 1 or any number between 1 to 126, you will say it is class A IP. Similarly, the same logic, if the first octet is from 128 to 191, it is class B IP. If it is 192 to 223, it is class C IP. If it is 224 to 239, it is class D IP. If it is, let's say, class E, it will be 240 to 255. So that is how your IPs are designed. So, but good part is you need not to worry for class D and E at the moment. Class D is reserved for multicasting. So here we have multicasting. Okay, so you will understand later on maybe. And then you will have class E. It is for future purpose, not future purpose, it's already being used in R&D, so satellite communications and all, everything is being done on class E. So that is nothing to do now. Okay, so class A, class B, and class C, these are the IPs that you will be dealing with as part of your job, as part of your studies and all, whatever you will be dealing with, these are these classes. So now if I have to say my IP belongs to class A. Okay, so if my IP is 10.11.12.1, so what is the difference between class A and B? So now I want just move 15 more minutes. You guys just be interactive so that we can have good session. Otherwise, I'll be keep on talking alone only. So 10, 12, 10, 11, 12.1, this is one IP given to you. How you will be finding it useful? Why they might have divided all these things into classes? What was the need of the classes? What do you think? So why class A is different than class B? Yes? Any idea?
Yes, ma'am, because of network part and host parts.
Yes, so that it's not just a number. It is like, it's not just a number if it is starting between this number and all. It is basically your IP, number of IPs that you are getting. If I am using any number of class, any IP of class A, so let's say I start with 1.0.0.0. This is class A stuff. Okay. So, but what do you mean by 1? Can I write also 0.1.1.1? This is not valid because I just said we cannot start anything with the 0 at the moment. Okay. It's too early to understand this thing. So now 1.000, what is the meaning of 1? What is the meaning of second octet? What is the meaning of third octet? And what is the meaning of fourth octet? In IP address is not just a random number. It will be telling you, because you see you are trying to open any web page and that web page reply exactly coming on your laptop, exactly tab of Google Chrome or whatever the internet browser you are using. So that means IP address is not just a number, it is your location also. So for example, let's say if I have to say I have identification called Shiva dot not like this. I'll go for, let's say, ECS, then dot daily dose, then day 2, then Shiva. How you will understand this one? And if I have to write Kabir, what will be the notation for this one? It will be ECS dot daily dose dot day 2 dot Kabir. Similarly, if I have to write Satyam, then it will be ECS dot Satyam dot day 2 dot not Satyam here. Daily dose, day 2, and then Satyam. Okay. So now what did you find here in common? You see these first 3 things are same. And similarly, if there are devices who are your neighbors, we say they belong to the same neighborhood. But we don't use the term called neighborhood. We say they belong to the same network. Similarly, the last part is your actual identification. So that we normally say it is host ID. So in this case, this is your network ID because it is talking about which group or which neighborhood you are the part of, and then this is actually your serial order within that group. So now similarly in every IP we do have two parts. Okay, so every IP is consisting of two parts. One is called network address, we call it network ID, and another one is called host ID. So in class A, we have in fact B and C also. So the situation is like every class is having the notation. Class A, you have first 8 bits are for the network. It will look like in binary, it will look like this. 1, 2, 3, 4, 5, 6, 7, and 8. 1, 2, 3, 4, 5, 6, 7, 8. And this part will also be given to host part. Next one will also be host part. And next one will also be the host one. So this is the same theory we will apply on class B also. But now what will be the change in class B? In class B, first 2 octets are showcasing your network and last 2 octets are showcasing your host ID. What about class C now? Class C, you have, so I can go for class C. Okay, so this is what we do have. In class C, first 24 bits are for the network and the remaining 8 are for the host ID. So if you will calculate, this is 8 bit for the network. Here we have 16 bit for the network and here we have 24 bits for the network. So that is the reason we say class A is having 8 bits for the network. So that means if you will say any IP, and in order, the next thing that you have to give with IP, it is called a subnet mask. Okay, so that is called your subnet mask. In this subnet mask, you have to say along with your IP, let's say my IP is 10.11.12.1. This is my IP. Let me write IP here. Next thing, this number of 8 network bit will be identifying where is the network ID and what is the host part out of it. So you have to say, whenever you are calculating subnet mask, you are actually giving like this. So you are saying wherever the network part is there, you just saying everything is masked. Mask means full. You have to say this part of IP address you cannot change here. So it is like 111.1, 5, 6, 7, and 8. Rest all zeros. Okay, so that means you do not have just IP. You have every IP, you have a subnet mask along with this. So now that means if I have this IP, I'll be calculating it in decimal, I have a subnet mask associated with this one. What is the subnet mask right now? It is 255.0.0.0 in decimal. So now if you understand, can you give me the subnet mask for class B? If any IP you will see, what will be the subnet mask of class B? Yes, because subnet mask will always represent your class. So subnet mask will be, it's not depending upon what is the number you are able to see. So yes, number will be identifying the class and it will be similar to all the host IDs. All the people who will be belonging to the same network, they will have the same subnet mask. So it is like which network? So they are representing your network. So now what will be the subnet mask of class B? Because you have 2 octets are full now. So it will be 255.255.0.0. Similarly for class C will be 255.255.255.0. So that is all about your classes. Now any question for me? Tell me. All good?
Yes, ma'am.
Okay. So you have to just understand every class there will be a logic behind subnet mask. Okay, every IP is is always having one subnet mask. That subnet mask is giving you the idea what is the nature of this IP. Okay, so now last 5 minutes we have to start using those things practically. Let's say I have 1.0.0.0 and also I have 1.255.255.255. So that means here which class it is belonging to? It is belonging to class A. So that means network is 1, but host part is completely 0. Is it making sense? Are you guys understanding what I'm trying to say? Here host part is completely 0. And what about this one? Here host part is completely 1. So we have, these are the special IPs. Whenever you say you have host part is completely 0, this is called your network ID. So I'll say this is called the network ID. Okay. So if the host part is completely 1, it is called broadcast ID. What is so special about network ID and broadcast ID? So they will be having these are the special values. It will be representing your group. So for example, I will say Satyam, Kabir and Shiva, you all belong to ECS daily dose dot day 2. So I'm not talking about individual person, I'm talking about now the group of people at the same time. Similarly, let's say I have to share one book with you, all of you. I won't say Satyam, okay, send it to Kabir, I want to send it to Shiva, I want to send it to. No, I will use this destination IP as destination. It will automatically send everyone who are present in the network. So that is the broadcast one. What about any other IPs? Other IPs, they will start from, we will start giving the first IP from the last octet. So this is a rule again. You cannot start with any other combination. You have to start with always like this. 0, 1, then 1, 0, 0, 2. Similarly, it will go up to 1.0.0.255. Now, what about other one? Now you have exhaust the last octet. That means you have given first 256 people or 255 people with the IP. What will happen to 257th or 256th person as per the calculations? I'll explain it later on. So the next guy will be having 1.0.1.0. Is it my network ID? No, because the rule is broken over here. You see, at least one bit is non-zero. So you have to have all 24 bits in a row, completely 0 if you want to calculate the network ID. So now you have 1.0.1.0. Next value will be 1.0.1.1. Similarly, 1.2, 1.3, and so on. You will go up to 1.0.1.255. Similarly, you will start with 1.0.2.0 and you will end at 1.0.2.255. Similarly, you will have 3.0, 4.0 like that. And now eventually you will come at 1.0.255.0 and you will end at 1.0.255.255. Now you have exhausted how many IPs so far? 2 raised to power 16 IPs are already gone. 65,536 IPs are already gone. But still you have a room. You now start with the second octet. You can go with 1.1.0.0. And after that, 1.1.0.1. Similarly, you will end up at 1.1.0.255. Next value will be 1.1.0, not 0. It is 1.0 and you will go up to, as per this notation, okay, or maybe I can go one step ahead, 1.1.1.1 and you will end at 1.1.1.255. So now I'll be a bit quick here. 1.1.2.0, you will go and end up to 1.1.2.255. Similarly, 3.0, 4.0. So the things will keep on going like this. Now you will come back here 1.1.255.0 and you will end up at 1.1.255.255. You see, you just finished one rotation of this value, this 1.1. Same thing will now, if I have to tell you, you have started from here and you ended here. Okay, so that means what was my starting IP? Starting transition 1.1.0.0. Where did you end? 1.1.255.255. Similarly, you have to have the idea now. 1.2.00 will lead you 1.2.255.255. Similarly, 3.004.00 and so on. These things will keep on going like this. Now you will come at 1.255.0.0 and also you will end up at 1.255.255.255. That is what exactly your broadcast ID that we said. That is how your IPs are being populated. Class A, total IPs are huge. So that means it will depend upon the number of host bits. So in class A, you have huge range of requirement. So that means you can go up to 2 raised to power 24. So it will give you almost 16,777,216 IPs in one network. So that one network, what is the meaning of one network? I have started giving IP from 1.000 and I am ending at 1.255.255.255. So total, these many IPs are actually covered. Similarly, in class B is now easy to understand. You will go from any network, if I have to denote it here. So it will go from network.0.0.0 as the network ID, and it will go up to network.255.255.255. That will be the broadcast ID. In class B, it will be network.network.0.0. Your broadcast ID is going to be network.network.255.255. Similarly, your class B will having how many IP addresses? Because you have 16 bits for the host part. It is 2 raised to power 16 total. 2 raised to power 16. That will be 65,536. Okay, so now if I talk about class C is having network.network.network.0 and you will end up at network.network.network.255. So 8 bits are total for the host part. You see it is clearly visible here. So that means 2 raised to power 8 will be equal to 256. So you will be going from 0 to 255 range. So that is how your IPs will work. I hope maybe it is useful little bit. There is a lot of things other related to IP also, but this is what the pure fundamental. If you understand this, that means you understand everything later on. Okay. So whatever I have covered in this sheet, I will be sharing with you all later on. Okay. So I'll be sharing everything. Okay, I'll change the name later on maybe. So I'll be sharing with you this. Okay. So any questions for me now? All good?
Yes, ma'am.
Okay. Okay, so thank you. So we will see tomorrow. Tomorrow's discussion will be on subnetting part. So that means if you have understood this one, subnetting will be easy. If you did not get anything from here, subnetting is going to be a little tough job. Okay, so I'm going to wrap up now. So thank you everyone. Thank you very much. So I'll see you all by tomorrow.
Thank you, ma'am. Bye.
Bye bye.
Thank you, ma'am.
Bye.